So the problem here is that the basic idea, the original idea of fuzzing comes from different architectures and from different use cases. So usually fuzzing was used to fuzz single applications that process binary input. So the fuzzers are very strong in doing binary mutations. They are very good. They are started together with the target application, which is a single compiled binary, and they are fuzzing single functions. But this is not really the use case when you want to do your API fuzz testing or your API testing, because when you want to do API testing, maybe in the background, you have a lot of microservices, so you don't have just one single application. Maybe you also don't want to fuzz just single functions. Actually, you want to fuzz or test your whole API. And also, these microservices, they usually they are called by using HTTP requests. Maybe they are talking REST protocol or SOAP or gRPC. So they are more structured, expecting more structured inputs. So this is why fuzzing is not that common in API testing. But this is also why we've created our out-of-process fuzzer for CI fuzz. And this is what I will show you today, that actually using the basics, the feedback loop from fuzzing, we can fuzz microservices, we can fuzz web services in a microservice architecture in a very good way. So how does it work with our out-of-process fuzzer? So the idea is we have our fuzzing engine here, and we want to test a service, a web service. So our fuzzer will send HTTP requests to this service. And we can mutate inputs in these HTTP requests to test all types of parameters. But then we want to do white box fuzzing. We want to know how much code coverage did we achieve. We want to know, is this input that the fuzzer generated, is it interesting or is it not interesting? And this is why we will deploy agents together with all the services from this microservice architecture. So if these services work together, we will deploy an agent with each of them. They can run on multiple hosts. That's not a problem. It's only important that when we start our web service, we will also attach our agent here. And then when our fuzzer sends HTTP requests to the left service, the agent from this service will give the feedback back to our fuzzer to tell what code coverage did we achieve, what's the behavior of this application, was there an SQL injection or not. And then when this service also talks to the other services, these agents will also report back to our fuzzer, and they will also give the same information about if we achieved new code coverage, if we have found an SQL injection. So it is possible that our fuzzer sends an HTTP request to the left service, and then we have an SQL injection actually on this right service. And we will observe this because we have our agents everywhere. And in the end, we can also say exactly how much code coverage we achieved.